Okay, so here is a sketch, worst one I've drawn in a while, of the function y equals sine x, or y equals sine theta. We know that the sine of 90 degrees is 1, the sine of 180 degrees is 0, the sine of 270 is minus 1, and then it comes back to 0. So you get this endless wave-like pattern that continues to the right and to the left. So let's see what kind of measurements we can take for this. Its domain is all the x values it's defined for, and starting at 0, it goes on forever to the right and forever to the left, so there are no restrictions on its domain. Any element of the real numbers is in the domain of sine x. Its range is more limited, though, because in the y direction it does not go forever. It goes up to 1 and never gets any higher than that. It goes down to minus 1 and never gets any lower than that. So the range, you can put y as an element of the real numbers if you want, but it's restricted to the numbers between minus 1 and 1. Amplitude. The quick version, this is its midline, the x-axis, and from there you can see it goes 1 unit up to the tops of the hills, or 1 unit down to the bottoms of the valleys. Just from that we could get that the amplitude is minus 1, or the rigorous way to find it is you do the maximum value minus the minimum value divided by 2. The max is 1, the minimum is negative 1. You get 1 plus 1 is 2, divided by 2 is 1. That's our amplitude. Period. Starting from 0, this is the midline, and rising we go up over a hill, down into a valley, and then we're back to the start when we're ready to start another hill. That took from 0 up to 360 degrees, and so we say our period is 360 degrees. Or, if we were speaking radians, we'd say the period is 2 pi. For x-intercepts, well, there are a bunch. In fact, there's an infinite number of them. And you could find them by algebraically solving the equation sine x equals 0. You'll find you get a solution at 0, and 180, and 360, and 540, and so on forever in either direction. So the intercepts happen at every multiple of 180 degrees, or at every multiple of pi. And to be complete, I should probably say that pi is an integer. Y-intercepts, well, it only crosses the y-axis once, and that happens right at the origin, so the y-intercept is at 0.